The very first day at class, we looked at the W's of statistics, including the who and the what. What information and characteristics did we record? We looked at variables, which is what has been measured and recorded. So the types of variables we have are categorical, we also know it as qualitative variables, and quantitative variables. The thing to keep in mind is that categorical splits it into what? Categories. The easiest thing to keep these straight in your head is that quantitative variables are variables for which it makes sense to do arithmetic, like adding, subtracting, finding the average. The easiest one to think of is finding the average. So when I see something, I ask myself, does it make sense for me to find the average of these values? If it's something distinct, like favorite color, or whether or not someone owns a car. But when we get to some other types of variables, it gets confusing whether or not it is categorical or quantitative. So let's look at these, and I want you to take a second, pause, and think through what you think the answers are to these. So the first one is a rating system of superior, good, average, or poor. Well, it really doesn't make sense for me to do the average of those values because they're categories, so that one is clearly categorical. How about time in seconds to run a mile? That's quantitative. Social security numbers. So a lot of times people will see numbers and think, oh, it's quantitative. But does it make sense for me to find the average of someone's social security numbers? No, this is categorical. How about student test grades ranging from 1 to 100? That's quantitative. Heights of people recorded in inches. Also quantitative. Zip codes. Here's another one that trips people up because it's a bunch of numbers, but it's in fact categorical, and it's categorizing people by location. So now on your sheet, you should have at the top of the page, it says types of variables, quantitative and categorical, and it just goes through what we just said for the definitions. And I want you to put a Q or a C in each of the boxes, and we're going to debrief those and talk about anything we think with those in class the next day. So if we want to analyze data, we begin by examining each variable by itself and determine its type. Is it quantitative or categorical? And then we start looking at relationships among the variables. And we often start with a graph or graphs, and then we start adding numerical summary. So the first rule of statistics is to make a picture. Did I make a big enough picture for this slide? Graphs should follow the area principle, use an appropriate scale, and be honest and accurate. So the area principle is that, say I have something that is 50% and something that's 20%, then the area, if I'm doing, say, a pie chart, we should have it's representing 50%, and then here's my little piece of 20%. It should actually match with areas. And at first you probably are thinking, well, that's really obvious, but we're about to look at some bad graphs where they don't necessarily follow this principle. So I call this math with bad graphs, and you have a full sheet front and back. I have a clearer picture of this on Google Classroom because some of them it's hard to see the shading. And we're going to discuss what you think is the issue with these different graphs, going back to the fact that you want to have it follow the area model, use an appropriate scale, and be accurate. So obviously we don't want to do those horrible pictures that you just looked at. We want to make good pictures. So what is a principle we can use to make good pictures? We should follow the Tulsa principle. T stands for title. We should always have a title at the top of our graph. We should always, always, always put units. Hopefully your science classes have emphasized that with you. L stands for label. Label the axes. What do they represent? S is scale the axes. And A, make sure it's accurate. So we have three common graphs if we're talking about categorical data, which we're going to talk about for a little bit. We have a bar chart, which we put either frequency or relative frequency, so something like this. You've seen these a lot. Then you have a pie chart. Also spend a lot of time on those, which is relative frequency. And a segmented bar chart, this might be new. It's where you have one bar and then that bar is split into things using relative frequency. I keep using this word. What is it? Frequency is how many times the value occurs. Does it occur 5 times? Relative frequency is relative to the whole. So maybe when it has a frequency of 5, its relative frequency is 20%. So in this example of this table, what am I given right here? I'm being given relative frequencies because they're being given to me in terms of percent of the whole.